Simple pendulum. Please look here. Yesterday I discussed simple pendulum. Simple pendulum means heavy point mass, heavy point bob is attached to the massless, inextensible light string. Massless, inextensible, torsionless string. This total arrangement is called simple pendulum. Here Nana, simple pendulum length measured where to where means point of suspension to center of mass of the bob. Okay? This is called length of the pendulum. Okay? In the length of the pendulum measured, once again repeat, center of mass of the bob to point of suspension. This pendulum pulled aside and left to free. Because of restoring force, it will be oscillate. Yesterday I discussed restoring force over tangential force formula is mg sin theta, and derive another more formula, that is time period of the simple pendulum. Time period of the simple pendulum is 2 pi under root L by G. Time period means time taken to complete one oscillation. Next, another more topic, frequency. Frequency, some textbooks denoted by F, some textbooks denoted by mu, some textbooks denoted by small n. Frequency means number of oscillations made per second. Frequency definition is reciprocal of the time period. Its meaning is 1 by 2 pi under root G by L. Please look at. Please look here now. The condition is for a given place. Please look at. For a given place. Here Nana, once again I repeat. For example, pendulum is suspended here. For a given place means Nana, place does not change. Small g value is constant. Small g on the surface of earth, small g value on the surface of earth 9.8 meter per second square. Small g on the moon 1.6 meter per second square. Its meaning, G changes, pendulum changes one planet to other planet. Place is constant, small g value also constant. Now I am going to discuss time period of the simple pendulum. T is 2 pi under root L by G. Here G is constant, 2 pi is constant. Simply, time period of the pendulum mainly depends upon the length of the pendulum. Please look at. G is constant, 2 pi is constant. Constant terms neglect. Now we can write directly proportional. Its meaning time period depends upon the length. Please look at here t directly proportional to L. Its meaning is t square directly proportional to 1 by L. Please look at now. T square directly proportional to L because root will be cancelled. Squaring on both sides, root will be cancelled. Please look at Nana here. This is the x-axis. This is the y-axis. On the y-axis, t square taken. Nana, t square taken on y-axis, length of the pendulum taken as x-axis. Please look here. Length of the pendulum taken as x-axis, t square taken as y-axis. Its meaning y-axis physical quantity and x-axis physical quantity is directly proportional. Its meaning is the graph shape is straight line. Again I repeat, y-axis quantity, x-axis quantity both are directly proportional. Graph shape is straight line. What is the LT square graph shape? Straight line. Please look at. Next Nana, please look at all of you. Here, please look at Nana. Length of the pendulum taken as x-axis, time period taken as y-axis. Length of the pendulum taken as x-axis, time period taken as y-axis. In this situation, please look here. Y directly proportional to root x. Squaring on both sides, y square directly proportional x. Please look at now. This is the formula. T can be taken as y-axis, L can be taken as x-axis. In the situation, y square directly proportional to x according to formula. Okay? This is called in the mathematics parabola equation. So this is the shape of the graph. Please look here. This is the y square directly proportional x graph. Here simply this is the shape of the graph. This is the LT graph Nana in the simple pendulum. This is the LT square graph in the simple pendulum. Please look here. Here Nana, what is the condition for a given place? Given place, G value is constant. Please look at. Nana, look here all of you. Length of the pendulum taken as x-axis, t square taken as y-axis. What is the shape of the graph? Straight line. Suppose t square replace, here t can be taken. The graph shape is parabola. Look here. On the same paper, L taken as x-axis, t square over t taken as y-axis. This is the two graphs. In this point, both the curves are intersect. At intersecting point on the y-axis, both are intersect means t are equal to t square. Again I repeat, at intersecting point, this is t over t square, both are equal because both the curves intersect. Both the terms are equal. T cancel. Finally, what is the T value? 1 second. On the same paper, L can be taken as x-axis, T over T square taken as y-axis. Intersecting point time period is 1 second. In the same situation, to determine length of the pendulum, this is the question. Please look here. What is the time period of simple pendulum formula? 2 pi under root L by G. Okay, in the situation, T formula 2 pi under root L by G. Given place G is constant. G is constant. Here then, time period value intersecting point is 1 second. Please look at 2 okay, 5 okay. Here length of the pendulum is calculated. G value is on the surface of earth 9.8. Squaring on both sides, 1 square 1, 2 square 4, pi square whole by L by 9.8. Squaring root will be cancelled. Pi value we know that 3.14. Pi square 3.14 into 3.14 9.85. Approximately both are cancelled and finally L value is approximately 1 by 4. 1 by 4 write as 0.25 meter. It approximately write as 25 centimeter. What is the length of the pendulum? 25 centimeter. For a given length, means here according to question, length is constant. What is the time period of simple pendulum formula? T is 2 pi under root L by G. Here L is a constant. Simply time period of a simple pendulum is inversely proportional to root G. Please look at. L is constant. Time period of the simple pendulum inversely proportional to root G. Root G. Please look at. Please look at. Time period of the simple pendulum inversely proportional to root G. In the situation, please look at. Here length of the pendulum constant, time period mainly depends upon the gravity. In the situation, the first question. Simple pendulum shifts one planet to other planet. Please look here. Simple pendulum shifts one planet to other planet. Nana, planet to planet. For example, Earth to Jupiter. What happens? The G value changes. We know that relation between small g and capital G. Small g equal to Gm by R square. This is the gravitation formula. Already upper also continuation of gravitation. This is the relation between small g and capital G. Small g equal to Gm by R square. In the situation, T inverse proportional. Here small g. Small g write as g m by r square. Here g is called universal gravitation constant. Simply in the universe its value is fixed, its value is constant. Proportional is there, constant value is removed. It reverse root r square out r by root m. This formula is very useful. The question is pendulum shift one planet to other planet. Here r is called radius of the planet. Here m is called mass of the planet. Please look here. R is called radius of the planet. M is called mass of the planet. This is most useful Nana. Pendulum shift one planet to other planet. Please look at Nana. Here Nana, this is the earth Nana. This is the earth or our planet. This is the pendulum Nana. Initially pendulum placed on the surface of earth. Now the pendulum shift some height. Please look here. Initially pendulum on the surface of earth. Now the pendulum shift a height h from the surface of earth. Please look at. Initially pendulum on the surface of earth. Now the pendulum shift at a height h from the surface of earth. Here earth radius is capital R. In the gravitation, what is the radius of earth value? 6,400 kilometers. Radius of earth value 6,400 kilometers. Here the pendulum shift here to here, what height h. In the situation, initially pendulum on the surface of earth, its g value is 9.8. But now the pendulum at some height where g is vary, g is change. At height increases, variation of g decreases. Again I repeat Harshavardhan, this pendulum moves here to here, g value decreases. Now the g value at height h formula is g by 1 plus h by r whole square. Initially on the surface g. Now at some height gh value g by 1 plus h by r whole square. We know that time period formula T inversely proportional to root g. Now T2 by T1 right side neatly write as under root inversely. Here G1, here G2 inversely. Please look at G1 is on G Nana because initially pendulum on surface of earth. G2 is G by, please look at 1 plus h by r whole square. G what? Cancel. What is the T2 by T1 formula? It will be reverse Nana under root 1 plus h by r whole square. Square and root what? Cancel. Finally T2 by T1 is 1 plus h by r. H is height of the pendulum from surface of earth. R is radius of earth. What is the radius of earth? 6,400 kilometers. Okay. Here pendulum is initially on the surface of earth. Now we are going to discuss pendulum takes some height h. This is the formula, Nana. Please look at. Please look at, Nana. This is the earth, Nana. In this situation, pendulum initially on the surface of earth. Now the pendulum is going inside the earth. Here the depth is d. Please look at. Initially pendulum is on the surface of earth. Now this same pendulum taken some depth, Nana, d. In this topic, depth is measured from surface of earth. Here radius of earth is taken capital R. In the situation on the surface of earth, g value g. Here depth increases, gravity decreases, Nana. G2 formula is G into 1 minus d by R. Again I repeat, this pendulum is moving inside the earth. Inside the earth, gravity decrease. At some depth, a new gravity formula is G into 1 minus d by R. Here d indicate depth, Nana. R indicate radius of earth. This pendulum shifted at center of earth. A new gravity is 0. This will be discussed tomorrow. Okay? First one. Here now, T universally proportional to root G. According to this situation, T2 by T1. T1 is initial time period. T2 is final time period. G1 corresponding time period T1. G2 corresponding time period T2. T2 by T1 neatly write as G1 by G2. What is the G1 value, Taha? G. What is the G2 value, Taha? G into 1 minus d by R. G cancel. What is the formula for T2 by T1? T2 is T1 by under root. Please look here. 1 minus d by R. Here d indicate depth, R indicate radius of earth. Length of the pendulum comparable to radius of earth. Very important concept. Please look here. Length of the pendulum. This is the earth. All of you look here. This is the earth. This is the pendulum. Pendulum placed on the surface of earth. This length of the pendulum comparable to radius of earth. Its meaning is length of the pendulum is very large. Length of the pendulum is very large. Okay? In this situation, time period of the simple pendulum is 2 pi. Please look at under root 1 by. Please look at now. This is the pendulum, Nana. Its length is very large, very large, comparable to radius. In this situation, 2 pi under root here 1 by G, 1 by L plus 1 by r. Derivation is not required, none. Please look here. What is the formula? Length of the pendulum is comparable to radius of earth. Its meaning, length of the pendulum is large in this situation. Time period of the simple pendulum formula is 2 pi under root 1 by g into 1 by L plus 1 by R. 1 by L plus 1 by R. Here L indicate length of the pendulum, R indicate radius of the earth. Radius of the earth's value is 6400 kilometers. For example, I take infinite length of the pendulum. Please look at. I take infinite length of pendulum. I take infinite length of the pendulum. Infinite length of the pendulum means its length of the pendulum is taken infinity. Simply putting L value infinity, 1 by infinity is 0. Finally we get, I take infinite length of the pendulum. Infinite length means L value taken as infinity. In this situation, time period of the simple pendulum formula is G into 1 by R. Reverse R by G. Putting R value 6400 kilometer. Kilometer means 1000 meters. Putting G value 9.8. Pi value 3.14. It is finally 5086 seconds we get. It approximately 84.6 seconds. What is the time period of infinite length of pendulum? Time period of infinite length of the pendulum is 5086 seconds. Here 84.6 seconds. 84.6 minutes. Nana, what is the time period of infinite length of the pendulum? Infinite length of the pendulum 84.6 minutes. ORR, ORR 5086 seconds. Here time period means time taken to complete one oscillation. The pendulum placed, first one, inside the artificial satellite. ORR. Yet very important concept, Harshavardhan, at center of earth. ORR. The pendulum placed inside the artificial satellite. ORR. At center of earth. ORR. Lift. Freely falling body. Freely falling lift. The pendulum is suspended inside the artificial satellite. ORR at center of earth. ORR freely falling lift. In these three cases, we know that acceleration due to gravity is 0. The pendulum suspended. First case, inside the artificial satellite at the center of the earth, and again another case is freely falling lift. In the three cases, small g value is 0. Now time period is determined. time period of the simple pendulum 2 pi under root L by G. This is its G value is 0, 1 by 0, infinity. Its meaning time period of the simple pendulum is infinity. What happens to the frequency? Frequency means reciprocal of the time period. Its meaning is 1 by infinity. Frequency of the simple pendulum is 0. Its meaning frequency definition number of oscillations made per second. Here number of oscillations is 0. Its meaning is no oscillations. Its meaning is the pendulum does not oscillate. The pendulum does not oscillate. When the pendulum does not oscillate, the pendulum suspended inside the artificial satellite at center of Earth or freely falling lift. In this situation, the pendulum does not oscillate. Its meaning, its time period is infinity. Its meaning, time taken to complete one oscillation is infinite time. Its meaning, the pendulum does not oscillate.